Hi guys, hope you're all doing great. So before we start on anything, I want to wish you all a very happy new year 2024. And if you haven't subscribed to this channel, please do it because we are doing a lot of discussions on SRE, automation, DevOps, and software engineering. So please do subscribe. And also, if you think that we are making videos which can be helpful to others, please do share it as well. So in this particular video, we are going to discuss about the concepts of chaos engineering and the 5 best tools through which you can perform chaos engineering. Yeah, so this is not a sponsored video. So whatever the tools which I'm will be discussing, it is particularly which I have used personally, and that what I'll be sharing with you all. Yeah, so let's get started. So first, let's understand what is chaos engineering. So by definition, chaos engineering is a discipline of performing or adding different experiments into the system through which you can identify the weaknesses in the system. So how is this getting helpful? So as an SRE or as a software engineer, it is important that we take care of the reliability and availability of the application. Yeah, and today's applications are very complex in nature, and we have different architectures. So particularly for application which is designed under microservice architecture, so it is quite important that if you have multiple services running under some cluster, so there is more possibility that there could be a breakage in the communication between services, or there could be a performance issue, or there can be scaling issue. There could be other issues as well. Correct. So to address or to identify those weaknesses, we perform chaos engineering. So basically, you are adding some chaos in the system, particularly on the production environment. I will discuss it. When we are saying production, it is more like a controlled production. So we'll discuss later in the video. So basically, you are adding some experiment here, right, in the production, and then you are trying to identify those weaknesses and fixing it proactively, because otherwise that would turn out as an outage in the future. So that's the whole concept of chaos engineering. And there are principles also to perform chaos engineering. So the major part is that you need to take care of the blast radius of chaos engineering, or whatever the test you will be running on the production environment. So when we say blast radius, it is something that you are saying that whatever you are running the test, it should not happen that you are considering the whole of that application together. So you have to identify a small area, and then you need to add some different kind of experiments, correct? And once you try to understand those experiments and understand the system slowly, that you will also raise the bar or raise the radius of the blast, correct? So that is the whole concept of chaos engineering. So why we are doing this? Because we don't want, as an SRE, we don't want to work proactively. Don't want to run in reactive mode. We want to work as proactive, correct? So this is the whole exercise. We are doing it so that we don't turn out the things as an outage in future. Okay, so let's discuss about the 5 best tools. So number 1 is Litmus. So Litmus is a tool which is specifically designed for applications which are on cloud. So they have very good experiment list. They have inbuilt experiments which you can run specifically for Kubernetes, or whether you are on AWS or Azure or on GCP. So basically, you can run those experiments which are very specific to Kubernetes and specific to cloud services. So they have inbuilt experiments for all 3 major cloud service providers. Number 2, which is Chaos Mesh. So Chaos Mesh is another tool which is very specific for cloud applications, and it is very close to Litmus. But my preference is Litmus because they have this project, or this application is being acquired by a company called Harness, and in open source community it is listed in CNCF. They have very rich source of experiments. So I have personally used this tool, and they have very good UI as well. So I think Litmus is better than Chaos Mesh, but again, we have to, if I give a second name, it is Chaos Mesh. So Chaos Mesh is also very similar to Litmus, but it doesn't have that good inbuilt experiments in the list. Otherwise, it is more or less very similar to Litmus. Let's talk about the third tool, which is Gremlin. it is a great tool, but it's paid one. You can perform the chaos tests using Gremlin, but it is a paid tool. So if you have budget in your project, so definitely I will recommend that you go with Gremlin, because they have well-defined experiments, and since it's paid tool, so you'll get lesser bugs in the system. Yeah. So let's talk about the fourth tool, which is Chaos Monkey and Chaos Toolkit. So these two tools were actually developed under Netflix. So this chaos engineering term was actually came from Netflix company. So they basically created such stream where they were facing some reliability issues, and then they created their in-house tool called Chaos Monkey and Chaos Toolkit, and later they just made it open source so that others can also use it and contribute in the GitHub. So this is also a great tool, and I will definitely recommend it for the application which are based on Spring Boot, but also they have capabilities of running the Kubernetes based applications, so you can definitely use for cloud applications as well. So this is also a great tool, and it is open source, so you can definitely go ahead with this as well. Okay, now let's discuss about different kinds of these chaos experiments, and where to run these chaos tests. Basically, the strategy on how to perform these different tests. Correct. So let's talk on that. So particularly, if I talk about on examples of chaos experiments, so or either we can also call these as chaos tests. So chaos tests or chaos experiments are more or less the same thing. So it's a different way of saying. So these chaos tests or experiments are more like, for example, you're deleting a pod, and you're checking whether your pod is getting scaled or not. So this could be one of the examples. So what you're doing is that your application is already running. So you identify your steady state application, and now as an experiment, what you're doing is you're trying to delete a existing pod. So using any of these tools, so what you're doing is you are injecting a problem where you're saying that, hey, delete my particular pod. When you delete that pod, so now you will check what happens to the application, whether your application is going down, if you're saying you have 24/7 availability, and how your infrastructure is basically behaving in that particular chaos. Correct. So that could be one of the examples. And that could be like deleting a Kafka topic, so where you are specifically deleting some Kafka topic and seeing whether your communication is happening or not. This could be another example of chaos test. And then you can think of as an you are creating some network latency between the communication of different services. So you can include those, and you can also set some examples if you are adding some network latency. So how is your communication happening from the UI? So that could be another test. Fourth, I can remember is you can also create CPU stress and memory stress. So in experiment language, it is called hogging. So CPU hog or memory hog, you can do it. So to identify whether if your memory or your CPU is exhausted, so whether your pod is getting scaled or not. Correct. Because once you have that horizontal scaling, for example, and you're trying to exhaust all your resources, so you can see how your application is behaving, and then whether your pod is getting another pod is getting scaled up or not. That could be another example of chaos experiment. Correct. So these are the small experiments, and if you observe closely, so I'm taking very small area and then doing a blast. So there could be another experiment which is at larger scale. So you are deleting some node, for example, or maybe you can deleting some machine, correct? A whole VM. You're stopping some VM. So these are the major experiments which you can also perform in these different tools. But you need to start from very small, correct? So this is a part of strategy. So start from a very small area, and particularly on pre-prod environments. So not directly on production. So you need to identify. So I'm just discussing upon the strategy part, how you should run your experiments, correct? So as part of this strategy, so you basically make sure that you start with small area, and then understand the system, and then gradually you increase the blast radius. And once you do that, you need to also make sure that whatever the experiments which you are running is on pre-prod environments, not directly on production. So you need to identify an environment which is very close to your production environment, and then you are running those experiments on that pre-prod environment. And once you get confidence, then you should run those experiments on production. Basically, idea is that we have to understand the weakness of the production environment, but we don't want to jump directly in production, so that, because this is also a very risky thing, right? Because you are adding some problems, and then it can also harm your customer, because it is not a simulation, it is creating an actual problem, correct? So go ahead with production, but beforehand you have to do a lot of homework before actually performing any experiment on production, correct? So on that term, so you need to start with pre-prod, and once you understand these experiments, so in whatever the tools I have discussed, you can automate these chaos tests and include in your CI/CD pipelines.